Welcome to our next lesson on simultaneous equations. In this lesson we will be creating equations to represent practical problems and then solving the equations to find the answer to the problem. You have seen this idea before. There was an example in a previous lesson about destroying planets and satellites where we had to generate the equations. However, we are now going to extend this to more complicated problems using the skills learned in the last lesson where we had to multiply our equations first before we could solve them. So let's recap what we needed to do in order to do that. So first of all, always check what you've been asked to find. Once you know what you're calculating, what you're finding, then define your chosen variables. You can choose anything. We usually use x and y, but you need to write down what the x and y represent. That's defining your variables. When you've done that, make your simultaneous equations, give them the information in the question or the problem, and then solve them. And then once you've got your answers to your simultaneous equations, you haven't quite finished. You should always go back and check what you've been asked to find, and you need to write down your answers. So interpret the answers to your equations in the context of the original problem. So write down a conclusion, basically. So let's look at our first example. 1 week, Claire earns £6.78 for delivering 18 magazines and 43 newspapers. The next week, she earns the same amount for delivering 6 magazines and 52 newspapers. How much does she earn for delivering each item? That is what we've got to find. How much she earns for delivering each item. So how much she earns per magazine, how much she earns per newspaper. Now I know what I've got to find. I'm going to define my variables. So let x equal amount earned per magazine and y equal the amount earned per newspaper. So I've now defined my variables. Next job, make the simultaneous equations. So 18 magazines and 43 newspapers is £6.78. Because I'm likely to be dealing in small amounts at the end, I'm going to change the pounds into pennies. So I'm going to make this equation 1 will be 18x plus 43y is equal to 678. You don't have to change to pennies, but sometimes it's useful. And the next one, 6x plus 52y is equal to 678, and that's equation 2. And let's check our coefficients. They're different for x's, they're different for y's, so I can't just add or subtract to eliminate one of them. I've got to change by multiplying. I want to change one of them. I'm going to change this till it says 18x, which means I need to multiply the whole of this equation by 3. This one is going to stay the same. 18x plus 43y is equal to 678, and this one I'm going to times by 3 to get 18x plus 156y is equal to 2034. So equation 1 is still equation 1, and this is now equation 3. So I'm going to eliminate x because they have the same coefficient. I'm going to do equation 3, take away equation 1 because it's got the biggest amounts of y here. So 156y take away 43y is 113y. 2034 take away 678 is 1356. Do the division to find y, and the answer is equal to 12. So y is 12. And I'm going to substitute into, I think I'll go back into 2. So substitute into 2. And I get 6x plus 52y, so that's 52 times by 12 is equal to 678. So 6x plus 624 is equal to 678, which means, taking away 624 from both sides, 6x equals 54, x is equal to 9. So now I've solved my two simultaneous equations. I know that x is 9 and y is 12, but I haven't yet answered the question. Remember, the question is, how much does she earn for delivering each item? So the answer to my question then is going to be Claire earns, so x is amount per magazine, so 9p for each magazine, and 12p for each newspaper. That she delivers. So a nice written conclusion at the end. Now it's your turn to pause the video, and I would like you to have a go at exercise 10D, question 1 only. I'm going to do one of the ones from question 1 as an extra example if you want to watch it. If not, just pause the video and get on with it now. It should take you about 10 minutes, I think. So here is our extra example for those who want it. And this is statement D. I'm going to do statement D from exercise 10D question 1 on page 185. This is what it says. The sum of double two numbers is 100. Their difference is 20. So let the two numbers be x and y. So double x is 2x, double y is 2y, and I want the sum of that. So 2x plus 2y is 100. That's what that top line says. So that's the first equation with x and y. The second one says their difference is 20. So mathematically the difference is if I take them away from each other. So x take away y is 20. That's equation 2. So those are my two equations, and you should be able to find those. I think that's A in the second column, so that matches to A in the second column. And we now need to solve those. So as you can see, we don't have the same coefficients for either x or y, so we're going to have to do a multiplication. So those, I'll just write them down again. 20, equation 1 and 2. This one's going to stay the same. This one I'm going to double. And I can now choose to eliminate either x or y. I am going to eliminate y. The signs are different, so I'm going to add them together so they will cancel each other out. So I'm going to eliminate y. So I'm going to do equation 1 and equation 3, and I get 4x is equal to 140. So 140 divided by 4 is 35. So x is 35. Then I'm going to substitute back into 1. I get x take away y, so 35 take away y is equal to 20. 35 take away 15, so y is equal to 15. And let's just double check that, shall we? Go back to our original statement. The sum of the double two numbers is 100, so double 35 is 70, double 15 is 30, 70 and 30 is 100, that works. And the difference between them, 35 take away 15 is 20, so that definitely works. And you should see that is an answer. Also, answer in the third column, it's a top answer, alpha. Okay, so now it's up to you to do the rest of those. And then we'll come back and do a second example. So welcome back, I hope you've finished doing the question 1. We're going to look at a second example here. It's very slightly different in that we haven't got any variables to define. We can see here it's a shape question. We've got a triangle. It says the perimeter of this triangle is 70 centimetres and we need to work out how long each side is. So that is what we've got to work out. But there's nothing specific. It's not like the magazine and the newspapers question, because all the sides are a mix of either x or y or both. So we're going to use the properties of the triangle that we're looking at. We know, according to the top line, that the perimeter is 70. So the perimeter, 5x plus 7x minus 6y plus 5y, that's all three sides added together, is equal to 70. Simplify this so it looks like the sort of thing that you've been used to seeing. 12x minus y is equal to 70. So that's one equation, which is not enough. So go back to our original shape and you can see what we're looking at is an isosceles triangle. That means using the properties of isosceles triangle. So this is the perimeter. So that's the fact about the perimeter. And using the fact about isosceles triangles, we know that this side is equal to this side. 5x is equal to 7x minus 6y. And put that into the form that we've been used to seeing, where the x's and the y's are on one side and the numbers are on the other, and we end up with nothing is equal to 2x minus 6y. So I now have two equations. So let's write them out as we're used to seeing them. 12x minus y equals 70, equation 1. 2x minus 6y is equal to 0, which is equation 2. Neither of them have the same coefficient. I'm going to multiply this second one by 6. That will give me the same number of x's, and that's negative 36y. That's still nothing. And then I'm going to do a subtraction. I'm going to do equation 1 take away equation 3. Purely because this has got the biggest number of y's on it. Because we've got negative y and negative 36y here. So when I do the subtraction, I'm going to do 12x take away 12x is nothing, negative 1y subtract negative 36y, which is going to be 35y. These are always the hardest, because it's very easy to make mistakes. 70 take away nothing is 70, so y is equal to 2. If you chose to do it the other way, 3 take away 1, you'd end up with negative 35y is equal to negative 70. So you still get exactly the same answer. And so I'm going to substitute into equation 2. So substitute into 2, and I get 2x take away 6 lots of 2 is equal to nothing. So 2x take away 12 is equal to nothing. 2x is equal to 12. X is equal to 6. Oops. There we go. But I haven't answered the question, because the question said, how long is each side? So my triangle, 5x, and that's 7x minus 6y, but I know it's exactly the same as that, and this one here is 5y. So the triangle, and an isosceles triangle, with sides 5y is 10, 5x is 30, and the two sides that are 30. Let's double check in that 7x minus 6y. So 7x is 42, take away 12 is 30, so we know it works. And there's the answer to that example. Okay, so now time for you to finish these off. I would like you to do exercise 10D, just questions 2 and 4. You don't need to do 3 unless you have time. Just a quick hint. On question 2A, it's a similar question about sums and differences. Except this time it asks you at the end for the product. Remember, the product means two things multiplied together. So the product of 3 and 7 is 3 times 7, which is 21. And also make sure you've read the question carefully, that you answer the question rather than just write down the solutions to the equation. Okay, until next time. Don't forget to mark your work.